Hi everyone, this is Janine Co, aka Janine The Tutor. As you know, now is a very difficult time for each one of us, whether you're in middle school, high school, or university. Many students and families are deeply affected by the recent school closure, and as a part of OneClass, we are very fortunate that we are able to adapt to the situation quickly, and that's why we want to extend our helping hand to students to stay on top of their studies. That's why we are running free and daily classes for math and chemistry from grades 11 to first year college and university. In addition, we are also giving away 100,000 hours of free private tutoring. So if you're interested, make sure to scroll down below and book your time slot. So for today's class, I will be going over Algebra 2, so we'll just do graphing for equations. Just wanted to know if you guys can see my screen and also if you can hear me coming through. Okay, great. So for the first question, we need to solve the system by graphing, and we have two equations, right? And they're asking us for the solution, right? So whenever we have two equations, right, or system of linear equations, we need to think about when we're graphing, we need to find the point of intersection. So how do we find the point of intersection? Well, we need to graph them, right? So for the first equation, right, so in order for us to graph the first equation, we would have to isolate just y, right? So we would have 2y, which is equal to 3x, so this is positive 3x, and this is plus 8 divided by 2. So you end up with y is equal to 3 over 2x plus 4, right? And then on the other hand, because we also need the point or the slope-intercept form of x plus 2y is equal to negative 8, again, this is just for preference, but I think it's just going to be easier for you to graph your equations if they're in your slope intercept form, and that's why it's in the form of y is equal to mx plus b, right? But let's say we're taking this x plus 2y is equal to negative 8, and we're just isolating y. So we would have 2y, which is equal to negative x minus 8, right? Dividing both sides with 2. So y is equal to negative 1 over 2x, and this is minus 4, right? So now that we have both equations in slope-intercept form, we're ready to graph them. Okay, again, anything that is in black would be your x and y axis. Okay, so this is your y-axis and this is your x-axis, right? Okay, so the red one would be the first equation, right? So because we have an intercept at 4, that's what we're going to do. And we're going to plot 4 first. So we have rise of 3, run of 2, right? That means it's somewhere here, right? So 5, 6, 7. So 1, 2, 3, run 1, 2, right? Because it's 3 over 2. So our slope is rise over run. And it's supposed to pass these 2 points, right? Okay, great. So once we have that, let's plot the purple equation. So this is negative 4, so that's somewhere here, right? And we have to rise by 1, run of 2, right? So it's 1, 2. So that's somewhere here, right? Because we need to go up by 1, right? So this is negative 3, and this is basically negative 2, right? And we notice that when you plot these 2 points, you're going to see that you have a point of intersection, and that's what we need to find out. Okay, so it's meant to pass this point and this point, right? Because you have a y-intercept at negative 4. Okay, great. So once we have that, right, in order for us to find the solution, right, because we know that this is y is equal to whatever this x is, and we also know that this is y is equal to, again, another equation of x, since they're both y, we can just equate them to one another, right? So we can just have this being negative 1 over 2x minus 4, which is equal to 3 over 2x plus 4. And we're just solving for x, right? So because this is 3 over 4, I mean 3 over 2 rather, then you could just move the 1/2, right, to the opposite side of the equation. So you would get 3 over 2 plus 1 over 2, right? So that would be 2x, right? And then on the other hand, because you're moving this to the opposite side, you would end up with -8 because it's -4 minus 4, which is -8, dividing both sides with 2. You get x is equal to -4, right? So now that we know that x is equal to -4, right? So what about our y, right? So we know that the point of intersection, right? And how do you find the point of intersection of two lines? Well, you just have to equate the two equations, right? So you end up with x is equal to -4. So in order for you to find the y coordinate, right, when x is equal to -4, you just pick any of the equations. So you can pick this or this, it doesn't really matter. And you're going to plug in -4 in x. So you would have, let's say, 3 over 2, right? I'm just using this equation. Again, there's no preference. So you have 3 over 2 times -4 plus 4, right? So we can see that this can be simplified. So this is 1 and this is 2. So this is 3 times -2, that's -6, and this is plus 4, right? So we see that this is going to be -2, right? So y is equal to -2. So our point of intersection over here in the blue point, this is -4 comma -2. Therefore, our solution would be -4 comma -2. So simple as that, right? So again, whenever we're looking for systems of linear equations and we want to find, or I guess solve for the solution, therefore we need to graph them, find the point of intersection, and that's it. Okay, so let's proceed to part B. So we have x minus 2y, which is equal to 4, and we have 3x plus y, which is equal to 5. Okay, let me try to move this up and see. Okay, so for part B, again, we're going to isolate y, right? Okay, let's use the same color just for consistency. So for equation 1, this is equation 1, so I'm labeling that as 1, and this is basically 2, right? So for equation 1, when we isolate y, we have x minus 2y, which is equal to 4, and this is -2y, which is equal to -x plus 4. Dividing both sides with -2, you get x is equal to 1/2 x, and this is -2, right? 4 divided by -2 is -2. Okay, so once we have that, let's solve for the second equation. So this is 2. So this is 3x plus y, and this is equal to 5, right? And you know that this is y, right? We're isolating y. Therefore, I just realized that I wrote x here. This is supposed to be y. Okay, this is y is equal to 1/2. Yes, okay, great. So let's go back to that. So we have y, right? And we're moving 3x to the opposite side. Therefore, we need to change the sign, right, of 3x. So now this is -3x. Okay, I know that the y kind of is covering, or it's covering the negative sign, but it's -3x. And this is plus 5, right? So now that we have that, right? Let me just try to see if I can move the y. Okay, great. So yeah, it's pretty obvious that it's -3x. Okay, great. So once we have these two equations, again, we're going to plot this. So y-axis and your x-axis. So your first equation, we have 1/2 x minus 2, right? So in that case, this would be -2. You have a y-intercept over there, rise by 1, run by 2, right? So it looks like this. So this is your line for equation 1. And then for equation 2, because you have a negative sign over there, that means it's found in quadrant 2 and quadrant 4, right? And you have a y-intercept of 5, therefore it should be plotted over here. So this is 5. So now this is, okay, because I know that this is sort of short in terms of our y-axis, let's make that longer. Okay, now our y-axis is crooked. Let's make this, oh my goodness. Okay, hold on. Let's try this again. Okay, so it's a little bit longer, but let me erase the unnecessary points. Okay, great. So once we have that, now we're going to plot the purple equation. So 6, so rise by 3, 6, 7, 8, and then run by this, right? Okay, so notice how you have a point here, and because you have a negative sign, therefore your line should be found in quadrant 2 and quadrant 4, right? There we go. Okay, so as you can see, this is how your purple line should look like. Now, in order for us to find, and first of all, this is not your x-axis because it's not supposed to touch your point of intersection. So maybe we can move our x-axis. Okay, great. So it's not touching your x-axis. Okay, so once you found that you have a point of intersection here, right? Okay, so point of intersection, we just have to equate this and this, right? So we have 1 over 2x minus 2, which is equal to negative 3x plus 5, right? And we solve for x in this case. So that would be, okay, so we have negative 3x, so maybe if we can move that here, so that would be 3 plus 1 half. That would be 7 over 2x. And this is equal to 7, right? Because you have 5 and this is plus 2, so this is 7 divided by 7 over 2. So this is x, which is equal to 7, right? Because 7 divided by 7 over 2, which means you're taking the reciprocal and you're multiplying, so that's 2 over 7. Actually, this should not be 7, now that I wrote it. Okay, so this is 7 divided by 7 over 2, so take the reciprocal, multiply that, right? Just in case you don't have your calculator. So you're getting 2, right? So x is equal to 2. So from there, once you know that x is equal to 2, remember what I said, you're going to pick any of the equations that you prefer, and then you're going to plug in the 2, right? So maybe we can just take this, right? The 1 half. Okay, so you have x is equal to 2, so I'm taking 1 half times 2 minus 2. So I know that this is 1. 1 minus 2, which is equal to negative 1. Therefore, my solution would be, so this is at 2. Okay, so because it's at 2 comma negative 1, right? That means your y has to be at negative 1 and this has to be 2. So when you're trying to, let's see, plot this, right? So think about it. If you have your x-axis at 2 here, that means this has to be exactly at 2. So you need to shift your graph pretty much. So this is at negative 1, right? Because remember, we didn't really set up our table of values, but maybe we can change that and look exactly at 2 comma negative 1 for the point of intersection. Okay, so the point of intersection is somewhere here, right? So that should be over here. So that's the point of intersection. And again, because we don't have our graph or graphing paper, that means it's not going to be accurate. But when you're solving for your solution, right, it would be at 2 comma negative 1. Okay, maybe I can change this. I guess next time I can just like make the space bigger. I didn't realize that it was gonna look something like this. Okay, but anyways, this is 5. We can just scale that. And then you have a point here. And then you have this point of intersection. Okay, great. And then for the next question, now this is a little, yeah, it's a little bit different because they're asking us without graphing if the system is independent, dependent, or inconsistent, right? So first of all, what does it mean when something is independent, when something is dependent, and when something is inconsistent? So, okay, because we need the space, right, to graph that, maybe we can put it behind. Okay, so when you have intersecting lines, right? So first of all, what are intersecting lines? They meet at a common point, right? So that's what intersecting lines are. So if you have intersecting lines, so say for example, you have your x and y axis, right? And then you have this red line intersecting with the blue line. I mean, you probably know what intersecting lines are by now, right? But yeah, just for reference, this is what intersecting lines look like. So whenever you have intersecting lines, that means you only have one solution. Let's write that below. So you only have one solution. So SOLN means solution. I'm abbreviating my terms. And it's consistent, right? So when they say one solution, basically you only have one point of intersection. And then it's consistent, right? And on top of that, it's independent. So three things that you have to know for intersecting lines: one solution, consistent, and it's independent. However, if you have coinciding lines, right? So coinciding lines means two lines, they overlap. It's exactly the same equation. That's what it means. If you have coinciding lines, it would look something like this. So x and y axis. Okay, something like this, right? It doesn't have to pass through the origin, but it needs to be exactly the same line, right? Therefore, because they're coinciding, that means you can have infinitely many solutions. Infinitely many solutions. It's consistent and it's dependent, right? Because you have two lines. And then on the other hand, if you have parallel lines, by the way, anytime I show you the symbol, right, this is what parallel lines mean, right? In that case, you don't have any solution, right? Because you never intersect. And again, you probably know what parallel lines are by now, right? So these are parallel lines. Again, this is just to scale, right? So parallel lines, right? It's no solution because you never intersect, and at the same time, it's inconsistent. Okay, so I guess we can move on to this question. Okay, so without graphing, if the system is independent, dependent, or inconsistent. So just remember that if it's inconsistent, it's parallel lines. If it's dependent, it's going to be coinciding. I should write that down. Okay, let this be in green. Inconsistent means parallel lines. Dependent means it's coinciding. And for independent, it's intersecting. Okay, so once we have that, right, then how would you approach this question, right? So first of all, when something is parallel, right, so we know that if it's parallel lines, therefore the slope needs to be the same, right? If it's coinciding, it's going to be the exact the exact same equation, right? So if you have y is equal to 2x minus 1, therefore the other equation needs to be y is equal to 2x minus 1, right? Because they're on top of one another. But if it's intersecting, therefore you have a common point, right? Okay, so what we can do here is set this up into the slope-intercept form. So for the red one, right, again, this is going to be equation 1, right? So this is 4y is equal to 2x plus 6, right? Dividing both sides with 4, we get y is equal to, so 2 divided by 4 is 1/2 x, and this is going to be 6 divided by 4 is equal to 3/2, right? So this is the first equation, and then moving on to the second equation, right? Same thing, we're going to isolate y. So we have 8y is equal to 4x minus 12, dividing both sides with 8. So we have y is equal to, so this is 1/2 x, and negative 12 divided by 8 is equal to, yeah, negative 3/2. Okay, so if you're looking at these two equations, right, you can actually see that they have the exact same slope, right? The slope is 1/2. So what does it mean when the slope of two equations, right, are the same? That means they're parallel lines, right? Therefore, since the slope are the same, okay, let's pick this color. So since m is equal to 1/2, which is the slope, right, and it's same for both equations, therefore we can say that these two lines are parallel, right? And these two equations, right, when you solve for them, they're inconsistent. I'm listening. Okay, great. So let's move on to part B. So we have negative 3x plus y, which is equal to 4, and you have x minus 1/3y is equal to 1. So again, we're going to solve for y, right? So the second equation is in purple. So we have negative 3x plus y, which is equal to 4. So all we have to do is isolate y. So you would have y is equal to 3x plus 4. And on the other hand, yeah, this is pretty much done, right? And then on the other hand, if you have the second equation, you would have, let's see, we can have 1/3y, right? And this is equal to, so when you move y to the opposite side, you would have positive 1/3, and you would have x minus 1, right? Dividing both sides with 1/3, you would get y is equal to 3x, and let's see, if you have 1 times, yeah, it's going to be minus 3, right? Okay, so because again, as you can see, right, even though they're not exactly like 3x plus 4 or 3x minus 3, however, the slope is the same, which is 3x, right? Or the slope rather is just 3/1, which is 3. Therefore, it's going to be inconsistent because we know that these two lines are parallel, right? Yeah, so since m is equal to 3, right, this is the slope. Similar to this, right? This is 1/2 and this is 1/2. So same for both equations, therefore it's inconsistent. Okay, great. Let's move on to part C. So we have 2x plus 3y is equal to 1, and we have 4x plus y, which is equal to negative 3. Okay, again, it's going to be the same thing. We're solving for y, right? And we're making sure that we're in the slope-intercept form. Okay, slope-intercept form for equation 1. So we would have 3y, which is equal to negative 2x plus 1, right? Dividing both sides with 3. So you get y is equal to, let's see, negative 2x, yes, okay, this is negative 2 over 3, and this is plus 1/3. On the other hand, if we're looking at equation 2, right? Actually, we use purple, so let's just keep this as purple. Okay, equation 2, we have 4x plus y, so this is y is equal to negative 4x minus 3, right? As you can see, we have negative 4 over here, right? So the slope isn't the same, right? So maybe we can actually find the point of intersection, right? Because that's what intersecting lines really have, right? They have a common point of intersection. So if we plug in, actually, if we equate negative 2 over 3x plus 1 over 3, and that's equal to negative 4x minus 3, we can solve for x first, because we know that y is equal to y. So that would be in blue. So negative 2 over 3x plus 1 over 3. I'm taking this, and I'm equating this to negative 4x minus 3, right? I'm solving for x. So once we have this negative 4x, we can move this to the opposite side. So we get 4 minus 2 over 3, and that's equal to 10 over 3x. And this is equal to, so negative 3 minus 1/3. So this is, let's see. Yeah, negative 3 minus 1/3 is equal to negative 10 over 3, right? So dividing both sides with 10 over 3, so we get x, and because this is exactly the same thing, right? So this is just negative 1, so we're just going to carry that negative 1 over here. Okay, great. So yeah, I just want to make sure that we have that. So negative 2 over 3, yeah, this is 10 over 3, then you have, yeah, so it's negative 3 minus 1 over 3. Okay. So yeah, it's x is equal to negative 1, right? So how do you find the y, right, when x is equal to negative 1? So all you have to do is pick any of your equations. So it could be the red one or the purple one, right? So maybe we can pick this one because this is the easiest as opposed to fractions. So if you plug in negative 1, then you multiply this to negative 4 minus 3. So negative 4 times negative 1 is positive 4. 4 minus 3 is 1. Therefore, your y is equal to 1. So the point of intersection is actually negative 1 comma 1. Okay, that's it for part C. For part D, right, so we have y is equal to 2x minus 3, and you have 6x minus 3y, which is equal to 9. Yeah, we're going to do the exact same thing as to what we've been doing from part A to part C. So we're solving for y, right? Okay, again, the red one would be equation 1. So we have, okay, actually this is already y is equal to mx plus b, right? It's already in the slope-intercept form, so we don't really have to do much here. So let's proceed to the second equation. So we have 6x minus 3y, which is equal to 9. So we can say that this is negative 3y, which is equal to negative 6x plus 9, dividing both sides with negative 3. Therefore, we would have y, which is equal to, so negative 6 divided by negative 3 is actually 2x, right? And 9 divided by negative 3 is minus 3. So what can we say about the two equations, right? So because they're the exact same equation, so remember what I said, what does it mean when two lines are coinciding? That means they must exhibit the same equation. Therefore, if it's exactly 2x minus 3 for both lines, they're coinciding, and if it's coinciding, they're dependent. Okay, so they're dependent. And this is equal to this. Okay, let's move on to number 3. Okay, so now this is a little bit different because we're solving each system using substitution, right? So far, the previous questions we've been doing, we're trying to figure out if they're coinciding, if they're intersecting, and if they're parallel lines, right? But now we're actually looking at substitution, right? We're trying to solve x and y through substitution, right? And later on, we're going to look at elimination, right? So whenever we're trying to substitute, so here's the thing, it's not too bad. I know a lot of students just get overwhelmed and start asking me, okay, so what are you supposed to start with? Is it looking for y or x? It really depends. So if you look at this question, right, you know that just by looking at the second equation, so when I'm referring to the first equation and second equation, I'm referring to the first one being 3x plus 4y is equal to 12, and the second one being 2x plus y is equal to 10, right? As you can see, for the second equation, you already have y is equal to this, right? So this is not 4y, this is just simply y, right? It doesn't have any coefficient, it's just a variable. So that means you can just isolate y, right? You don't have to divide anything, you don't have to multiply this with a common factor, right? In order to turn this into y, right? Therefore, we would have to start with y. So that's how I typically start substitution. So when I see if my variable is just single variable, you don't have any coefficient, it's just 1, right? Therefore, I'm going to use y to begin with. So I would have y, which is equal to, so moving 2x to the opposite side of the equation, I would get negative 2x plus 10, right? And then once I have that, I would have to take this negative 2x plus 10 because I know that because I know that y is equal to negative 2x plus 10. So I'm going to take this negative 2x plus 10, I'm going to plug that into this y on my first equation. So keep in mind that whatever you have for the second equation or the first equation, right? If you've isolated one variable, right? Because the goal in math, right, is to be able to solve for the equation, right? You want to reduce the number of variables as much as you can. That's why we're using substitution, because we want to have just one equation either in x or y, and then we solve for that variable. So if we have 3x plus 4y is equal to 12, right, we're using y from the second equation, and we're turning this y into the form of x. So if you have 3x and this is plus 4, and your y is this, right, so you would have to literally take this negative 2x plus 10, plug that into your y. And what can you see, right? Remember what I said, the goal here is to reduce the number of variables, and now we're only seeing x, right? Okay, so once we have that, we're going to solve for x. So this is 3x, and this is 4 times negative 2, so this is minus 8x, right? So what do we have to do here? We have to distribute, right? So this is plus 40, right? 4 times negative 2x, that's negative 8x. 4 times positive 10, that's 40, and that's equal to 12, right? So I can see that this is 3x minus 8x, right? So that gives us negative 5x. And you have 40 over here, so if you move 40 to the opposite side, that would turn it into negative 40. So you would have 12 minus 40, and that's equal to negative 28. Therefore, I can say that my x is equal to 28 over 5, right? You can't really reduce 28 over 5, that's pretty much it, and just leave your answer in fraction. You don't have to convert this into decimal unless the instructions tell you to do so. So because we know that x is equal to 28 over 5, right? How do we find y, right? That's the next step. So, well, you know that x is equal to 28 over 5, just pick any of your equations, right? So let's say we're picking this, right? Because I know it's just one y, right? You don't have to multiply this to another number, so I'm just picking the second equation because I think it's the easiest. So you have 2 times 28 over 5, and this is plus y, which is equal to 10. Therefore, okay, 2 times 28 over 5, this is equal to 56 over 5, right? And this is plus y, and this is equal to 10. So once I have that, I'm just going to isolate y. So can you see now, and can you understand why I'm using the second equation? It's because I don't have to do as much work as possible, right? Because I already have y, right? It's not 2y, it's not 4y, so I'm not dividing this with anything. I'm just literally isolating y, and I have 10 minus 56 over 5, and that's it, right? So 10 minus 56 over 5, and that's equal to y is equal to negative 6 over 5. So yeah, basically my solution would be 28 over 5, right, comma, negative 6 over 5. Right? When x is equal to 28 over 5, y is equal to negative 6 over 5. So as you can see, whenever you're trying to do substitution and elimination, right, you want to reduce the work as much as possible because that's the beauty in math. Like, you're not supposed to overcomplicate things. Whatever you're seeing, just do that. Okay, so for part B, you have x plus 3y, which is equal to 5, and you have negative 2x minus 4y, which is equal to negative 5. So if you look at y, right, you don't really have any I guess any variable that's just 1, right, except for x. Can you guys see that? So all of your y's, right, compared to the first part, or part A rather, you can actually see that y is just 1, right? And your x, you have 3x and you have 2x, right? However, for part B, if you're trying to compare x and y, right, for y, you actually do have a coefficient in front of your variable. So you don't really want to isolate y this time. So you're going to isolate for x because x is just a coefficient of 1. And that's the simplest part. So if you have x here, that means you can just have x, which is equal to, so I'm taking equation 1 and I'm isolating x, right? Because compared to y, x has a coefficient of 1, right? And we want to isolate any coefficients that's 1, right, beside a variable. Because right now for y, right, it's 3y and this is negative 4y. Does that make sense? And you don't want to pick equation 2 because x is negative 2x. So, I mean, you could, but it just adds more work because you have to divide negative 2. Make sense? So that's why this is x, and you would have negative 3y, and this is plus 5, right? So once you have x, right? So here's the thing, you cannot use the same equation, right? So when you're trying to substitute something, if you're using equation 1 for the substitution, for the second equation, you cannot, I mean, you would have to use the second equation, right? You cannot use, like, let's say you isolated x, which is equal to negative 3y plus 5, and then you wanted to plug this back into 3y, right? You can't really do that because it's the exact same equation, and therefore there's no point, right, doing the substitution. So again, once you figured which equation you would like to use for substitution, that means you're using the other equation to solve for the variable, right? So now I'm using the second equation, right? Because I've used the first equation for substitution. So the second equation, we have negative 2, right? Anytime I'm seeing an x, you would have negative 3y plus 5. And this is minus 4y, which is equal to negative 5. So again, we wanted to reduce the number of variables if we can, right? So that's why it's only y that we're dealing with. And that's why we only have to solve for y. Okay, great. So once we have that, all we have to do is distribute, right? So negative 2 times negative 3y, that's 6y. And we have negative 2 times positive 5, so that's negative 10, minus 4y, which is equal to negative 5. Okay, so once we have 6y like terms, right, you combine them. So you have 6y minus 4y to give you 2y. And then on the other hand, on the right side, you have negative 10. So you move that to the opposite side of the equation, you get 10 minus 5, right? Which is 5. Okay, just to double check, negative 2 times negative 3y, that's positive 6y. Negative 2 times positive 5, that's negative 10. You have negative 4y, which is equal to negative 5. Like terms, right, you combine them. You have 6y minus 4y, that's 2y. Moving negative 10 to the opposite side of the equation, you get positive 10 minus 5, that's 5. Dividing both sides with 2, right, you get y is equal to 5 over 2. Okay, great. So we've solved and we've gotten rid of one of the variables, which is y is equal to 5 over 2. So now, like, our job right now is to find what x is, right? So x, right, I'm picking the first equation because, again, I want to lessen the work, right? So if you have x plus 3y is equal to 5, well, obviously, all you have to do is just plug in y, right? If you have y, which is 5 over 2, and you're just isolating x, So can you see that again? You don't have to do much work. You don't have to divide this a with a coefficient, right? Because it's already 1. Therefore, this is just x, and all you have to do is just multiply this. So this is 15 over 2, right? Moving that to the opposite side, so you get 5 minus 15 over 2. So yeah, you don't need to divide this with a coefficient, because if this was 2x, then you would have to divide this with 2. And that's why I'm picking the simplest variable, right? Because I don't want to do more math. Does that make sense? Yeah, because it's very inefficient. So if you have 5 minus 15 over 2, okay, this is actually equal to negative 5 over 2, right? So that's your x. So x is equal to negative 5 over 2. And guess what? I'm going to pick this equation, right, in order to solve for, actually, we do have y, so we're done. And we do have x, which is negative 5 over 2. So yeah, we don't really need to solve for anything. Okay, so this is negative 5 over 2, and your y is 5 over 2. So that's your solution. Okay, so for number 4, now we need to solve each system by elimination, right? Oh, and also, I think this is I guess a good question or a good concept to just go over, because I notice people who are taking the SAT, right? Because you're probably in high school, that's why you're attending my class, right? So let's say, right, you don't have a calculator, right? And you have 5 minus 15 over 2, and you wanted to calculate this without a calculator, right? So if you have 5 minus 15 over 2, right, this is what I would do. So if you have 5, right, so, and also you have an improper fraction, right? So this is 15 over 2. So let's write that here. Just a quick note. Okay, so 15 divided by 2, you want to make sure that this is a mixed number. Why? Because you have a whole number over here. So you want to make sure that this is a mixed number, therefore you need to have a whole number and a fraction. So when you have 15 over 2, so this is 15 divided by 2, right? So this is 2 times 7, long division, right? In order to turn an improper fraction into a mixed number, 2 times 7, that's 14. So this is 15 minus 14, that's 1. So this is 7 and 1/2, right? So once you know that this 15 over 2 is 7 and 1/2, right? So you're going to write this into 5 minus 7, and this is 1/2, right? And because you can't really just subtract this from 7 and 1/2, you would have to turn this into a mixed number as well, right? So when you're turning this into a mixed number, this needs to be 4 and this needs to be 2 over 2. And first of all, how did I know that I need to turn this into 4 and 2 over 2? Well, if you think about it, 2 over 2 is actually 1, right? So 1 plus 4 gives you 5, right? So on the other hand, the reason why your denominator needs to be 2, because remember the rule for addition and subtraction, you need to have the same denominator, right? And what's the denominator in the other term? It's actually 2. Therefore, the only way for this to be 5, right, or this to become 5 is when you have 4 plus 1, which is equal to 5. Does that make sense? Okay, so once you have that, right, you can actually go ahead and subtract this, right? And just so you're wondering what negative 5 over 2 is, right, long division again. So 2 times 2, that's 4, and this is going to be 1 over 2. So this is actually 2 and 1/2, and this is a negative sign over there. Okay, so you have 4 and negative 7. Okay, so this is now going to be, let's see. Yeah. Okay, so once you have 2 minus 1/2, so you're going to have 2 minus 1 over here, which is 1. And then you're going to see that this is going to be, let's see. Actually, I can just leave it over here, right? Because when you're solving for negative 5 over 2, right, this is essentially, yeah, negative 2 over 1/2, right? Which is, yeah. So I just wanted to show you I mean, this is not really related to the question, but I just wanted to show you how you're going to manually solve 5 minus 15 over 2 because I do get a couple of questions and sometimes students forget. So this is how you're going to break this down into mixed number, and then that's the time you go ahead and solve for it. Okay, great. Since I wanted to cover the majority of the questions. Okay, but anyways. So yeah, turn it into mixed number. So for part 4, we need to solve each system by elimination, right? So the difference between elimination and substitution is when you have elimination, you want to get rid of one variable, right? Which is the same, right? So as you can see, if you look at part A, you have 4x plus 2y, which is equal to 9, and you have negative 4x plus 3y, which is equal to 16. Because this is already 4x, right, we can actually easily get rid of this x, right, and just have y and solve for y. So that's the goal in elimination. That's why it's called elimination to begin with, right? You're trying to eliminate one variable at a time, and then once you get the variable, then you just have to plug that back into your equation and solve for the other variable. So because we know that this is going to be 4x plus 2y, which is equal to 9, we can actually multiply the whole thing with negative 1. So this times negative 1. Okay, and let me tell you why I'm multiplying this to negative 1, right? Because when you're eliminating two equations, when you're applying elimination to eliminate the variable x, right? You need to subtract the two equations, right? And for this to cancel out, you would have to have this being a minus sign, right? Or this being a plus sign. So when I multiply negative 1 to this first equation, I would get negative 4x. So when I multiply negative 1, I meant the whole equation, right? So distribute the negative sign into each of the terms. So negative 4x, and then you have minus 2y, and then this is equal to negative 9, right? So once I have that, and once you have the second equation, which I did not change, so I just have negative 4x plus 3y, which is equal to 16. So once you have this negative sign over here, because that's the goal in elimination, you wanted to eliminate one of the variables, and the one that's easiest to eliminate just by looking at this equation without multiplying any factor, that would be x, right? Can you guys see that? So that's why if you have negative 4x minus 4x over here, we know that this is going to become positive 4x, right? Because negative times negative 4x would give you positive 4x, right? So negative 4x plus 4x would just be 0, right? Simple as that. And then if you have negative 2y and this is minus 3y, this would give you negative 5y, right? So once you have negative 5y, then you have negative 9 minus 16. Does that make sense? So your negative sign gets distributed. So you have negative 2y minus 3y, so you're adding 3 and 2, and you're carrying the negative sign, which is negative 5y, and then you have negative 9, and this is minus 16, right? So negative 9 minus 16, this is equal to negative 25. Okay, so dividing both sides with negative 5, right, you end up with positive 5, right? So y is equal to 5, right? And how do we find x? We just pick any equation, right? So I'm picking the second equation. So I have negative 4x plus 3 times 5, which is equal to 16. Again, you can pick any equation. It doesn't really matter. So this is negative 4x, and this is plus 15, which is equal to 16. 16 minus 15 is going to be 1, right? So negative 4x is equal to 1 divided by negative 4. Therefore, x is equal to negative 1 over 4. So the system would be negative 1 over 4, or the solution of the system would be negative 1 over 4, comma 5. Yeah, and also I just wanted to remind everyone that you don't have to go this route. Again, this is math, right? There's a lot of ways or a lot of routes you can actually take in order to get to your answer, right? So let's say I wanted to eliminate y first, right? Because that could be a possibility. So if you wanted to eliminate y first, right? Since we don't have much space except for the bottom part. Okay, let me just copy this question again. So Okay, I guess it doesn't copy that. Okay, so this is 4x plus 2y is equal to 9. Okay, so this will be in black. So the question is 4x plus 2y is equal to 9, and negative 4x plus 3y is equal to 16. Okay, let's say we wanted to eliminate y first as opposed to x, right? That could be a possibility, but it's going to be a little bit complicated because you need to multiply 2y or 3y with, actually both in this case, to a common factor. Okay, so if you're looking at this over here, right? So if you have 2y and 3y, right? You need to think of a multiple of 2 and 3 specifically, so that you would have the exact same y for your coefficient, right? So the one that I can think of right now is 6, right? Because I can actually multiply 2 and it's exactly times 3, right? Which is going to give you 6y, right? And then on the other hand, because I know that I have 3y, then I can just multiply 2, right, to get 6y. So if we have 6y for both equations, then we can just easily eliminate y, right? So again, this is a much complicated one, but I mean it's possible, right? But I just wanted to present two ways to solve for this question. So this is times 3 and this is times 2. Okay, so once we have this, right, when we multiply this 2y, right, to get 6y, you need to remember that when we're multiplying this by 3, it's not just 2y, right? It has to be the whole equation, because otherwise it would be imbalanced, right? So that's why it's 4x times 3, which is 12x, and this is 6y, and this is equal to, so 9 times 3 is 27, right? Then on the other hand, you have negative 4x plus 3y is equal to 16. Then if you're multiplying this 2 with 3y, right, it has to be the whole thing again. So this is negative 8x. Then this is 6y. Then this is equal to 16 times 2 would be 32. So yeah, this is now 32. So as you can see, now they're similar, right, which is 6y. So you wanted to just go ahead and subtract the two equations such that you would be able to eliminate y, right? So that's what we're going to do. So equation 1 is the first one, and it's the one on top. So you have plus 6y is equal to 27. Then you have negative 8x, and this is plus 6y, and this is equal to 32. So once we've set up this equation, we're going to subtract the two, right? So 6y minus 6y is 0, right? And don't forget, we're trying to distribute the negative sign to each of the terms. So when we're reading this, this is exactly 12x minus 8x, right? So 12x plus 8x, right? Because negative times negative is positive. So 12 plus 8 is equal to 20x, right? And this is equal to 27, right? Even though this is positive 32, this is now 27 minus 32. So that's equal to negative 5, right? Dividing both sides with 20, right? We see that x is equal to, so this is divided by 5, this is 1, this is 4. So this is negative 1 over 4, right? And guess what? Based on what we've solved earlier, our x is equal to negative 1 over 4. Can you guys see this? Yeah. So it has to be the same, right? Even though, there's a different route to get to your answer, that doesn't mean that your x needs to be different. It has to be the exact same thing. So x is equal to negative 1 over 4, right? And how do you solve for y? Well, you're just going to take any of these two equations and then you're just going to plug in x and solve for y. So I'm taking the first equation. So I'm taking 12 times negative 1 over 4 plus 6y is equal to 27, right? So I'm solving for y, so I know that 12 times negative 1 over 4 is actually negative 3 plus 6y, and that's equal to 27. So this is 6y, and this is equal to 27 plus 3. So that's 30, right? Divided by 6. Okay, let's see. 12 times negative 1 over 4. Yeah, that's negative 3, and then you have 27. So 27 plus 3, that's 30. 30 divided by 6, that's 5. Let's see. Yeah, it's 5. Okay, so for some reason I thought it was a fraction. Okay, so as you can see, it's consistent. X is equal to negative 1 over 4, and your y is equal to 5. Great. So your x is negative 1 over 4, and your y is 5. So yeah, two different ways to get to your final answer, but your x and y remains the same. Okay, so because we only have 5 minutes left, right? And I wanted to take the time to actually do these questions. Yeah, so once again, before we wrap up, I just wanted to say thank you so much for, just attending my class and just listening to me. Um, I guess just listening to me, just learning math with me. I think right now it's very difficult, not just for you, but also for everyone who's learning, right? If you're interested, if you found this insightful and if you found this, I guess this class being as productive as it can be, right? I have my daily schedule here. So this is oneclass.com/livestream, right? So this is where you can access my daily schedule. And also, if you do have any friends, who wants to join, right? Because this is free and this is for anyone, right? Ask them to come join. I have my algebra classes Tuesdays and Saturdays, right? Just check my daily schedule because it does changes. So yeah, if you're interested, we do have other educators who are also doing live classes. They're free classes and they're daily classes. So check this website, oneclass.com/livestream. And without further ado, thank you so much for tuning in, and I'll see you on my next class. Bye, guys.